In this lesson, we're going to cover two things. We're going to cover the molar gas volume and we're going to cover the molar concentration of liquids. So let us go over the molar gas volume quickly. So now it is said that under standard temperature and pressure, so under standard conditions, standard temperature and pressure are standard conditions. So under standard conditions, 1 mole of a gas occupies a volume of 22.4 decimeter cubed under those conditions. So what are the conditions? The temperature should be 25 degrees and the pressure should be 101.3 kilopascals. So under these conditions, 1 mole of a gas will occupy this volume. 1 mole of a gas will occupy that volume under these conditions. So now we can use that as a conversion factor to find the number of moles or the volume, because we understand that at this condition, at a standard temperature and pressure, 1 mole of a gas will occupy a 22.4 decimeter cubed of volume. So we can move nicely from number of moles to a volume, from a volume to a number of moles, like we did in the other lessons which required our conversion factors. Now let us do an example. But before we do an example, let us look at a mathematical relationship that we can come up with from this conversion. So if you do not like to work with conversion factors, you can make use of this mathematical relationship between the number of moles and the volume occupied by the gas at SCP. So now the small letter n, as defined in the other videos which are covering the quantitative aspects, the small letter n is always the number of moles. The SI units are mole, abbreviated from moles. And then OV is for volume, measured in decimeter cubed, and OVM is the molar gas volume, and this is a constant. Learners need not to cram this number, but I always advise that they know everything that they are taught. So now this number will be given as a constant as part of their constants that are given in the formula sheets. Now let us try on an example of this one. So the question says, calculate the volume occupied by 2 moles of hydrogen at SCP. So under the standard conditions being temperature and pressure, as indicated earlier on, they want us to find the volume if we're given this number of moles at that condition at SCP. So at the mention of SCP, learners can use that formula to find either the number of moles or the volume occupied by the gas. Now let's find the volume. So there's our formula. So the formula is number of moles should be equal to the volume over the molar gas volume. So now we continue to substitute. We are given the number of moles, which are 2, and we want to find the volume of a hydrogen gas. We understand that Vm is the molar gas volume, which is always a constant of a 22.4. So if you cross multiply here, the volume occupied by hydrogen at standard conditions will be a 44.8 decimeter cubed. So that is how you can calculate the volume occupied by a gas at SCP. Also, one learner understand the conversion factor. We know that 1 mole should be equivalent to 22.4 decimeter cubed under these standard conditions. So what are we given right now? We're given the number of moles, so I'm going to write them under the 1 mole. So 2 is equal to, and then what exactly are we looking for? We are looking for the volume, so I'm gonna write it under this volume as well. So now we're given the number of moles, we are looking for the volume. So if you cross multiply here, what does this become? So 1 times the volume, we're gonna get the volume of a hydrogen equals to, again it's a 44.8 decimeter cubed. So that is how learners can perform this calculation. Now let us have a look at the molar concentration of liquids. So now what is concentration of a liquid? So a concentration of a liquid is simply the ratio of the solute to the ratio of the amount of a liquid that is present. So the amount of solute that is dissolved in a given volume of water is what we call a concentration. How much of a solute is present in a liquid? So the ratio between those two, the solute and the volume of a liquid, is what we call a concentration. So this is calculated we have a mathematical relationship for calculating the concentration. So that is how we're going to find the concentration of a solution. So we dissolve a solute in a given volume of a liquid. So the amount of a solute dissolved in a volume of a liquid. So UC is the concentration, and it is measured in mole per decimeter cubed. Those are the SI units. And then number of moles over a volume will calculate the concentration. But we understand from the previous chapter, we did look at this formula for the number of moles. One number of moles is calculated by mass over the molar mass. So this formula is equivalent to mass over molar mass times volume. So both these are calculating the concentration of a solution after dissolving a solute in a given volume of a liquid. Let us try on an example to make sense. We are required to calculate the concentration of a certain solution. So 10 grams of sodium chloride is dissolved in 500 centimeter cubed of water. Firstly, I need to mention that we don't work with our volume in centimeter cubed. So this should always be converted to decimeter cubed. So what we do is, if you divide the volume which is in centimeter cubed, if you divide it by 1,000, the answer will always be in decimeter cubed. So that means we need to divide the 500 centimeter cubed by 1,000 to get our answer in decimeter cubed. Now, let us continue. So the volume that we're working with here is equals to a 0.5 after dividing by 1,000. Decimeter cubed. Now, here's our formula. It says concentration is number of moles over volume. Are we given any number of moles here? No, we are not. What do we have? We have a mass. So learners can use this formula if they have number of moles, or they can use this formula if they have a mass. But also we understand that if you are given the mass of a substance, you can find the number of moles. Remember, we did mention earlier on in our previous lessons that number of moles are calculated by mass over the molar mass of a substance. So the mass of sodium chloride in this case is at 10 grams. And what is the atomic mass of these elements so that we can find the molar mass? So the atomic mass of sodium it's a 23 plus the atomic mass of chlorine being 35.5. So what is the answer? What is our number of moles? So we get our answer being 0.1709 number of moles present in that solution. So our formula says we should find the number of moles. We have found the number of moles. Now we can substitute and divide by the given volume. So we're gonna say this is a 0.1709 divided by the volume being 0.5. Remember, we're working with decimeter cubed than centimeter cubes. So now the answer here should be roughly a 0. Double that amount, a 0.34. Remember, we're calculating concentration, so the units should be mole per decimeter cubed. So that should be our concentration. Alternatively, learners, instead of calculating the number of moles, you can just substitute your mass, substitute the molar mass, and then multiply by the volume. So how will that calculation look like? So let me just put this on a side. So alternatively, learners can use this formula instead of this one. So what can you do in this situation? We are given the mass as 10 grams. So I'm going to substitute 10 grams on my numerator, and then I calculate my molar mass in bracket, or you can do a side calculation of the molar mass. So now this is going to be a 23 plus a 35.5, and then we multiply by our given volume. So the volume that was given to us in decimeter cubed, it's going to be 0.5 decimeter cubed. So this should give you roughly the same answer, being 0.34 mole per decimeter cubed.